Okay guys, now we are on Theorem 6. The proof of Theorem 6 is not examinable, so we're just going to be looking at what reason do we have to use when using this theorem, and we're also going to be looking at how do we prove that a quad is cyclic. So Theorem 6 says an exterior angle of a cyclic quad is equal to the interior opposite angle. Now, what is an exterior angle? In this example, ABCD is a cyclic quad, and we have C1 as an exterior angle. So if you take one of the sides of a cyclic quad and you produce a line extending it exactly from the cyclic quad, you're extending a line exactly from the cyclic quad. The angle that forms outside the cyclic quad is called an exterior angle. So an exterior angle is equal to the interior opposite angle. So in this example, C1 is the exterior angle and it is opposite to A. So C1 is equal to A. The reason that we use when proving this theorem is angles of a cyclic quad. Sorry, not proving. When we are using this theorem, we use angles of a cyclic quad. Let's look at the converse of this theorem. It says, if an exterior angle of a quadrilateral is equal to the interior opposite angle, then the quad is a cyclic quadrilateral. So here, you're told that you have an exterior angle that is equal to the interior opposite angle. So if you're told that, that means you have a cyclic quad. Let's take a look at an example. So this says calculate the value of the unknown angles. So to calculate x here is an exterior angle, and you can see that it is opposite to E. So x is equal to 88 because the exterior angles of a cyclic quad. That's the reason. So you have an exterior angle. You see a line that is extended exactly from the cyclic quad, and you have an angle outside the cyclic quad. So that angle that is outside is equal to the interior opposite angle, is equal to the angle that is inside. To calculate y, 105 is an exterior angle and it is equal to y, and the reason for that is still exterior angles of a cyclic quad. Now let's look at something that is super important. So this is examinable. They will ask you at an exam to prove that a quad is cyclic. Now there are three conditions that make a quad to be cyclic. So if you're asked to prove that a quad is cyclic, you can only choose one of these conditions. You can't use all of them. So you can just see what you have, and then you can use one of these conditions. So condition 1 is from Theorem 5, which says the opposite angles of a cyclic quad are supplementary, or they add up to 180. So here we have BAD plus BCD. So you have angle A that is opposite to angle C, and they add up to 180 degrees. And you also have ABC plus ADC. So you have angle B that is opposite to angle D, and they add up to 180 degrees. That comes from Theorem 5. Condition 2 comes from Theorem 6, and it says C1 is equal to BAD, which is C1 is equal to the C1, which is the exterior angle. It is equal to the interior opposite angle. And condition 3 comes from Theorem 4, which is the butterfly angles or the bow tie angles. So it says A1 is equal to D1, and the reason is angles in the same segment. So you have A1, which is equal to D1. So if you can prove these conditions, you can write down these conditions, and these conditions prove that a quad is cyclic. So that's it for this theorem. Please like the video, please comment on other topics you would like me to post about, and please subscribe.